question is about complex numbers. The complex numbers z and omega are defined by z equals 1 minus I, omega equals minus 3 plus 3 root 3i. Express z omega in the form a plus bi. So we just multiply, just expand using the usual algebra. So this is z, this is omega, we multiply. 1 times minus 3 is minus 3. 1 times 3 root 3i, 3 root 3i. Minus I times minus 3 plus 3i minus I times 3 root 3i minus 3 root 3i squared. Now remember here that I squared is minus 1. So this is minus 1 times minus 1 is plus. And now we can collect the real part. So the real part is minus 3 plus 3 root 3, and the imaginary part is 3 root 3 plus 3 times I. Now express z and w in the form r e to the I theta. So the z, previously we know that z is 1 minus I, and the omega is minus 3 plus 3 root 3i. So let's start by drawing the Argand diagram. So 1 minus I means 1 minus I, this is the point. So if you draw this triangle here, this is a right angle triangle. We have this length is 1, this length is 1, so it's an isosceles right angle triangle. To find the hypotenuse we use Pythagoras, and to find the angle, well, obviously it's 45 degrees or pi over 4, or you can use the tangent equals opposite over adjacent and do inverse tangent, you get pi over 4. For omega, the coordinates minus 3 root 3. So if you draw this triangle here, you will get this kind of triangle. So the length is 3 root 3. Use Pythagoras to find the hypotenuse and use inverse tangent beta. So it's opposite over adjacent, and do inverse tangent, you get pi over 3. So now for the exponential form, we use the hypotenuse or the modulus. So the r is the modulus or the hypotenuse, and the theta is the angle from positive real axis. So this is the positive real axis. Since it's clockwise direction, it's actually negative this angle, so negative the angle alpha, which is pi over 4. That's why we have minus pi over 4. This is the z in exponential form. For omega in the exponential form, the r is 6, and the angle is again from positive real axis. So this is the angle we have to use. The angle we found is beta, so we need to do 180 degrees minus beta, or pi minus beta. So pi minus pi over 3 is 2 pi over 3. That's why the final answer is using 2 pi over 3. So this is counterclockwise direction, so positive angle 2 pi over 3. Now on an Argand diagram, the points representing omega and z omega are a and b. Prove that OAB is an isosceles right angle triangle where O is the origin. Previously we have the z and the omega in the exponential form. When we multiply complex numbers in exponential form, we multiply root 2 times 6, we get 6 root 2. And when we multiply e to the power of, same base, we simply add the powers. So minus pi over 4 plus 2 pi over 3, we get 5 pi over 12. So this is the complex number ZW. So that means the length is 6 root 2, and the angle from positive real axis is 5 pi over 12 or 75 degrees. For omega is 6e to the 2 pi over 3, so the length is 6, and this angle is 2 pi over 3, which is 120 degrees in degrees. So if you draw this triangle here, you have 6 root 2, and this angle is 120 minus 75, which is 45. You can use the cos rule. So to find this side, we do the square root of 6 squared plus 6 root 2 squared minus 2 times 6 root 2 cos 45 degrees, and you will get 6. So since we know it is 6 and also 6, we know it's isosceles. And since 6 squared plus 6 squared, square root of, we get 6 root 2. It's like Pythagoras. That means we have an isosceles right-angled triangle. And the last part, using your answer to B, prove that tangent 5/12 pi equals. So previously we know that ZW is 6 root 2 e to the 5 pi over 12. So we have 5 pi over 12 and the 6 root 2 length. Now the argument is, or the theta is 5 pi over 12. And the if you look at this triangle here, tangent 5 pi over 12, so tangent this angle, tangent the argument here, this is a right angle triangle, is opposite. The opposite is 3 plus 3 root 3 over adjacent, which is minus 3 plus 3 root 3. So this is from SOHCAHTOA, definition of tangent. We divide everything by 3 here, divide both sides by 3, we get 1 plus root 3 all over minus 1 plus root 3, which is what we need to prove. Alright,